Hello everyone. Today we're going to work on part 2 of the basic Python. This is lesson 1 that we did in the previous video. You can find them on my website. I have a domain name, I haven't set it up yet, but it's here. You go to the tutorial tab on the top bar. So this is lesson 2. Today we're going to read data from files. So let's run this. Lesson 2. Plots and data reading. So we're just going to import pandas as PD, which pandas is for reading data, slicing and dicing, and just exploring it. But what we're going to do today is just basic indexing. Import matplotlib, import the magic command that just handles the displaying the graphs within the notebook. So we import this. Let's wait for it. I just restarted the notebook. And we do this. Okay. So I've taken some snapshots of an Excel file, and so let's display it. This is not within the lesson. This is just something extra. If you're interested in it, okay, look, you can look it up. So this is a snapshot. Notice that we have 3 columns. 1, 2, 3, and it starts from the up right corner. Our data begins from here. You can't have it starting from any random point in your table. Always start it from here. I don't know how to do the other one if it's somewhere else located. So let's read it. We just use the PD dot read Excel. That's how it is. And then we specify the location. Remember, the dot slash means that it is located in the same directory as with our notebook. So in the directory that the notebook is at, there's a data directory. In there is the Python basics. Let's see this also. See? This is the notebook we're working on. There is a data directory. And in here is this. These are just the screenshots of the Excel table. Okay, so let's read it. Boom. A, B, C, right? Indexing starts from 0, 0, 1, 2 are the data, are the rows. That's how we specified it. And that's about it. Now, let's assume that maybe there were different scenarios and we had to split our data into different sheets in Excel. Maybe experiment A, experiment B, or quarter A for a business, or quarter B, it doesn't matter. So let's see how that looks like. So again, we're going to work, this refers by default to the first sheet. So there's no thing here, you don't mention it. But if you go below, show example with sheet names, again, we'll just specify sheet 1, okay? It's the same data as above. Let's fix this. It's more correct. It's just deprecated, it wasn't wrong. So this, with the extra parameter here, is the same with this, because it defaults to the first sheet. So let's read the second sheet. The second sheet has D, E, F as the columns. So sheet 2, and that's that. Okay, so we're done with reading Excels. That's about it. Don't worry about the DF. DF is a data frame. There are many tutorials on YouTube if you wish to expand on it, but this is just an example to help you, to get you going. Now, of course, sometimes people will give us data in the form of a TXT file, meaning it will look like this. So I made 5 columns, A, B, C. I named one cheese and the other one chicken. It doesn't matter what it is. Okay, as long as it's properly structured. Let's read it. This is reading a CSV or TXT data. CSV and TXT are just basically the same thing. Just CSV specifies, you specify there that it's separated by a comma. Don't worry about it. You'll figure it out. So this is it. A, B, C, D, A, B, C, cheese, and chicken. So in case our data was not separated by a comma, but it was by a, by a tab each point, then we would have to define a different delimiter. Same as with Excel when we import data from text and we want to split it into a cell. You might have a comma as a delimiter, a Greek question mark. Well, that's about that. So you would just have to add delim whitespace in case it was a tab. True, or else you would have to specify a different delimiter. You can find that out in the documentation. So now let's see how we can access our data, because we need these columns. You know, maybe this is a Petri dish 1 or Yahoo Finance something, the volume of a stock. It doesn't matter what it is. So let's see how we can access it. We access it by df, which is our base. It's the data frame. df dot the column. Okay, but it's better to use df braces A, the name of the column. Therefore, when you want to loop over the columns, you can say for C in a list of A point, let's say B, doesn't matter, I won't add them all. You can say print df of C. So it would first loop pick A, second loop B. Let's see how that looks like. So that would look like that. But that's for different problems. So it's better to always use the curly braces, because maybe your columns will be numbered like 0, 1, 2. You cannot say df dot 1. It highlights it and it's wrong. And I'm pretty sure you can't say df dot 1 as a string. Sorry, or even A. Better not work. I hope it doesn't work. Yes, you can't. So you can't say dot a string, quotes. You have to go name of the column. So anyway, just always use the brackets. Now let's say we want to access the row. Let's say we want to access the first row, the 0 row. So this is the index. Might not always be this. You might want to specify, let's say, a date time here, a time, like 0 seconds, 1.1 seconds, 10.3, it doesn't matter. Anyway, so let's index it. First row, the location that refers to this value, df.lock. Okay? If you don't care about what this value is, it might say A, B, C, D. You cannot say lock of 0. That does not refer to the first element. You would have to use iLock. The I part lets you refer to as the row as a numbered row. So df.lock. I'll show the difference below. Don't worry about it. Again, you gotta practice. Once you fit these issues into your problems, either maybe you want to convert Excel spreadsheets into notebooks, make them automate some things so you just don't have to use the same Excel or change stuff, just use the data. You just need to work on it. Don't only work on this problem, try and fit it on a problem you've already solved. So let's make some plots. Again, we have df.plot. df.plot, we have 1, 2, 3, 4, 5 columns. If I type df.plot, it will plot 5 lines, and it will label them. You see? A, B, C, cheese, chicken. And it's a linear, in this case, it's a linear plot. The x-axis is our index. df.index is our index. The index, I said before, is the bold numbers here. If I were to change the index, let's say this index, the x values, they don't work for me. I need timestamps, or I need, maybe it's in seconds. Maybe our first measurement was 0, 0.1, 0.2, 0.3, 0.4, 0.5, or even 20. Okay? We will just say df.index and set it equal to time. Doesn't matter if time was an array, maybe it's a gigantic. It will still work. This will still work. It's up to you to decide. So let's set the index. Let's see what the df looks like now. See? The index has changed. Isn't that beautiful? So let's make a df.plot now. Again, plot everything. See how it looks like? Now, remember something very important here. Same way I plotted this, I can add all the graph tricks that we did in lesson 1. Meaning we can just copy all of this. We can copy all of this. And it will add everything. Graph title. Oop, I saved it by accident. Okay? But this is not part of the lesson. You just have to follow lesson 1, and that's about it. So we did this. We set the time. So, now, do you see this? We named the index. We gave it custom values, not the default when it reads it from the data. What won't work now? If I say df.lock of 1, that doesn't work. It's a key error. This number 1 does not exist in here. Doesn't exist. 0 does. 0 is the same as 0.0. It does. 0.1 does. But 1 does not. So you cannot access that row. What does work is ilock of 1, meaning the second row. 0, 1. The first element in a list or anything in an iterable is 0, the index of it. So let's say we want the second row has an index, has it's numbered as 1. It's 0, 1, 2, 3. That's how the numbering begins. So let's see how it looks like. Here we go. 1, 2, 3, 4, 5. Oh, you see? This is the index. Row, the second row has a value of 0.1. You see how it is? Let's see how this... Okay, yes. Don't worry about that. Okay, now, what if we want to plot a single column? Well, we did pick the columns before, right? That's how we index them. So let's say this is X and this is Y. Since we said that when we use the df.plot, it will use the index as X and the column as Y. So let's plot this. Boom. There it is. But it won't, I don't know why, but since we're not plotting the whole data frame, this gives you the labels of the lines. This won't. So in order to add them, we add our previous command we learned from lesson 1, plt.legend. And there it is. Maybe we wanted to plot in the same figure another one. Oh, doesn't exist, of course. B. Yes. Okay? Same as before. Everything is pretty much the same. For some reason, we decide to be backward people. We can define, as before, with our arrays or our lists from lesson 1, x, let's say, equals df, of course, dot index, right? Does this make sense? These are the values of x. This is our x-axis. And we can define y equals a row of our choice. We'll say chicken, okay? df.chicken. Okay? Okay, if instead of defining them here, I simply write them in our plt.scatterplot, or maybe I'll just use them since I defined them already. X, Y. We'll use the label chicken. We'll have to name it ourselves. Boom. And there's chicken. Let's say A. And there is A. Maybe we want to loop over them. So if we want to loop, this is what we would have to do. If we want to plot them all from a loop, which is, there's no reason to do that since you can just type in plt.plot. But let's say we want to loop. So we have to loop over the columns. So how do we find the available columns from our data frame? Well, of course, we would say df, since it's involved in our question, dot columns. Bang. And it gives us a list. A, B, C, cheese, chicken. We can access these columns. It's the same thing as a list. Okay? So let's say we want to plot these one by one. For column, we'll just use in columns. We'll copy this. Nope. Sorry. Yes. Let's take all this. Well, we can define x outside of the loop since it never changes. Say y, okay, and we have to remove the a here and write the word column. And of course, we need to change the label since column is the name of what we're plotting. Let's see this. And there it is. For some reason, did I mess up the data? df.plot. Why isn't it nice? Okay, let's go here and bring this down because I think it's messing with the scaling. Forgive me. Yep, okay, that's good. 1 minute. Yes, much better. Okay. So we know that x is the index and it never changes. We want each column, we'll print all. Let me print the word column so you can see it. Get the data from the data frame by column and make a scatter plot. And since we defined x out here, y in here, x equals x, y equals y, we also need a label. We need to know what this looks like. And we want to show the labels. So there it is. You can change this to the keyword plot, as we showed previously. Doesn't work. Don't worry about it. I'll find it out. So this is this. Okay? That's that. And that's that. Okay. A little more about data frames. This is off the record though. So we have our data frame. The same way we would apply operations to arrays such as multiplying them by numbers and anything else. We can do the same thing to data frames. So df plus 10 will add 10 to everything. Times 10 is this. Maybe these are concentrations. Maybe you forgot to add maybe it was 0.1, but it was nanometers, and you forgot to define the proper prefix. So maybe you want to find the max value. So this would find the max value. Let me have this showing. This will find the max value for the columns. So it's 98765. Okay? So this is, yes. Okay. Now this is very important now. Maybe these are A, B, C, D, E. Maybe these are just 5 different experiments and you're looking for the maximum of the row. Okay? In pandas and in NumPy, arrays are defined as this is the one axis, the vertical one, and the horizontal axis is called 0. So this is 1. Imagine just writing the number 1. And this is 0. So if I want to find the df max of axis 0, that would refer to going way down, following the axis 0, all the values, and finding that maximum. Maybe you want to find the mean of each column going down. The mean, 2.5, 3.5. This is the mean of A, the mean of B. Maybe you want to find the max of, let me just write these, sorry. Maybe you want to find the max of the row, of each row, meaning maybe for each time period, maybe whatever, maybe these are petri dishes measurements, you have like 5 per sample and you wanted to find the maximum value. So you say df dot max, and which way do you want to move? You want to move along axis 1, which is A, B, C, cheese, chicken. Axis equals 1. See? This index has max 4. See? 4, 5. It just so happens that it's always the last one, but it's not like that. Maybe you want to find the mean of this. Maybe you want an average, because maybe if these are the same experiments and you made more to reduce your error, you would usually want the mean per row, and you would usually want a standard deviation, maybe a max, whatever. So this is this. Finally, sorry, forgot my own commands here. Finally, maybe you want to save this data frame. Maybe you had a df2 minus df. Does this work? Yes. So we squared it. Oh, I love parentheses. We squared it, then we subtracted the original, okay? Maybe, and we'll name this DA. It's still a data frame, right? Oh, sorry. Maybe we want to save it. Maybe we want to save it to a txt file. So what will we do? Since we're referring to the data frame, DA dot 2, and of course, CSV. You can save it as an Excel. The other formats you're going to have to explore on your own. It's too complicated now. To CSV, well, what do we need to do? We need to name it. Okay, we'll name it output.txt. You can even write CSV, it doesn't matter. There's still TXT files. So let's see what this does. DA to CSV. Let's see what it gave us. Let's close this. Here it is. Okay. Now pay attention now. Oh, okay. It worked. So it exports it as it was. Okay. Now let's say we do not want this line for some reason. Maybe we just want the values. This is called the header, and this is called the index. Maybe we wanted that. We can say header, none. Is it none or false? We'll find out. Well, let's see now. Wait. It's either none. Let's see it. Yes, none. There's no header. Maybe this you want to enter this after in an array or something. I don't know. Use it in another program, and having a header breaks things. Maybe you don't want an index. Does this work? Let's see. Yep, no index. No index. It just starts immediately from A, B, C, cheese, chicken. Okay? So that's it. Next tutorial we'll probably talk about functions, and then I am going to convert a lab report. It's going to be written in Greek, unfortunately, but you'll get the picture with the equations, and we'll try and program the whole thing so we can just so anyone can use it with their own data.